Hello, my name is Bhavesh Nandan, and currently I am working as an assistant professor at the BP Mandal College of Engineering, Madhepura, which is under Department of Science, Technology and Technical Education, Government of Bihar. So today I am going to explain about this rectifier circuit. So why to learn about the rectifier circuit? So we know we are using chargers to charge our mobiles, and we are using different electronic circuit in which there is rectifier, and also we are using inverters in our home in which rectifier are used. So have you even ever wondered how AC is converted to DC for your devices? So to convert this AC into DC, we are using basically rectifier circuit. And rectifier circuit has many importance in electronics, like in mobile chargers. First, we are converting AC signal into DC, and in inverters also to charge the battery, we are basically converting AC signals into DC signals. So today's session's outcome today session in today's session we are going to learn about the different things like explain the working principle of half wave and full wave rectifier. Basically, rectifier is of two types, half wave rectifier and full wave rectifier. We will see these rectifier in details in a head slide, and we will also analyze the output waveform and characteristic of different rectifier circuit. And we will identify the key components of the rectifier circuit and their roles in converting AC to DC. And we will also compare the advantage and disadvantage of half wave rectifier, full wave rectifier, and bridge rectifier. And we will design a rectifier circuit to meet requirement. So to learn about the rectifier, we need some prerequisite knowledge, and these knowledge are about difference between AC and DC current, and we should also know about the diode working principle. How diode works. Basically, DC currents, here you can see, with the time, the current direction is not changing. For perfect DC, it will remain constant. And for alternating current, we are seeing that as per time, the voltage polarity or the current polarity is getting changed. So we have both positive current and negative current. But in DC, we have unidirectional current. And we should also have knowledge about the diode circuit. Here, the basic principle of diode is that uh, for forward bias, diode will act as a closed circuit, and for reverse bias, if we reverse the polarity of the voltage to the rectifier, means cathode we are having positive and anode we are having negative, then diode will not conduct the current and it will work as a open circuit. So this prerequisite we require to understand about the rectifier circuit. So what is rectifier circuit? So definition is that a circuit that converts AC to DC, means we are having AC current and we have to convert it to DC, then we will use rectifier circuit. So rectifier circuit is of two types, half wave rectifier and full wave rectifier. So what is half wave rectifier? Basically, AC is converted to DC, and if for one cycle, one input cycle, if output having one pulses, then it will known as half wave rectifier. And for one input cycle, if output having two pulses, then it is called full wave rectifier circuit. So we will see the circuit structure in details. So if polarity get reversed, then diode will act as a reverse bias because positive terminal of the source is connected to the cathode terminal of the diode. So it will act as an open circuit. If circuit is open, no current will flow and output voltage will be zero. So here for second half, or we can say for negative cycle, always output voltage will be zero. So for first cycle of input, we are getting one pulses in the output. So it is called half wave rectifier circuit. So now coming to full wave rectifier circuit. Here we are using AC voltage source, 4 diode structure. Basically it is forming the bridge type structure. And in between we are connecting load. So in this fashion load is connected and source, AC source is connected between these two nodes of this bridge configuration of diode. So this circuit acts as a full wave rectifier circuit. We are using oscilloscope to measure the waveform of input and output side. So this upper waveform is showing the input waveform of the source, and this lower waveform is showing the load voltage. So to analyze this, the working of full wave rectifier circuit, we are considering first the positive half cycle. So for positive half cycle of the input, you can see here that these two diodes acts as a forward bias and other two acts as a reverse bias. So this configuration will form like that, and uh, positive voltage will appear to the positive terminals of the load. So we can say output voltage is equal to the input voltage and polarity will remain the same. So this one is the equivalent circuit for positive cycle, where these two diodes is short circuit and the rest of the diode is open circuit. So here you can see the positive terminal of battery is connected to the positive terminal of the load, and negative terminal of the battery is connected to the negative terminal of the load. So output voltage polarity will remain the same. So now coming to second cycle, which is negative cycle, when polarity will reverse. So in this case here, polarity is getting reversed, means bottom side is positive and upper side is negative. So in this we are saying, you can say here that these two diodes will be forward bias and the rest of the two diodes will get reverse bias. So these two diodes acts as a short circuit and these two diodes will act as a open circuit. So coming to equivalent circuit of this, you can say we have replaced these two diodes by short circuit and rest of these two diodes by open circuit. So in this equivalent circuit, we are saying that now positive terminal of the source is connected to the positive terminal of the battery and negative terminal of the source is connected to the negative terminal of the battery. So here we are observing that when polarity of the source getting reversed, the circuit structure manage itself in such a way that positive terminals will remain connected to positive and negative terminal is connected to negative of the input supply. So if polarity of the source get reversed, circuit operation also changed. So that output voltage polarity will not change. So here we are seeing the output voltage in positive cycle is positive and in negative cycle it's remain positive because the circuit is acting that way. So coming to comparison about the half wave rectifier and full wave rectifier circuit, we have seen in half wave rectifier circuit we are using one diode and frequency is same as the input frequency. And output voltage will be lower in DC because we are having one pulses per cycle and cost will be lower because we are using only one diode. But in case of full wave rectifier, as we have seen, we are using four diodes and frequency is doubled of the input frequency because we are getting two pulses per cycle, so time period will be half and the frequency will be doubled and output voltage will be higher for full wave rectifier circuit. As we have seen, there is two pulses per cycle and definitely cost will be higher for full wave rectifier circuit because we are using four diodes. Yeah. So we can have different configuration for half wave rectifier circuit and full wave rectifier. Let's test your understanding whether you have understand this lecture properly or not. So can you identify the type of this rectifier? Whether this circuit will act as a half wave rectifier circuit or not. We have modified the diode connection here. We have reversely connected the diode. So by reverse connection, will the diode act as will this circuit act as half wave rectifier or not? You have to analyze this, and here this circuit is basically redrawn. I have redrawn the full wave rectifier circuit. The structure will remain same, but its appears somewhat different. So you can analyze this whether this circuit will act as a full wave rectifier or not. And if it acts as a full wave rectifier, what will be the output voltage? How it looks like. So uh, this analysis you have to do yourself. So for quick quiz, what is the function of a rectifier? So you can say what is the function of rectifier. Basically, what rectifier is doing, it is converting AC current into DC current. So which rectifier has higher DC voltage? Uh, we have seen the half wave rectifier circuit and full wave rectifier circuit. So for half wave rectifier circuit, output voltage will be lower, and for full wave rectifier circuit, output voltage will be higher because we have two pulses per cycle. And also go through the definition of ripple. So coming to practical applications of the rectifier. So real world application of rectifier circuit, we are using mobile charger and in different AC loads. If we have some DC generator, and we can convert it to DC using rectifier. For homework, you have to design a bridge rectifier and calculate its efficiency. Okay, go through some textbook and try to design a bridge rectifier circuit and calculate its efficiency. So coming to conclusion of this session, uh, so we have understand about the rectifier circuit. So two types of rectifier circuit is there. One is half wave rectifier circuit and second one is full wave rectifier. And its working principle we have also seen. Separately, we have to analyze for positive cycle and negative cycle, and we have to see whether diode will act as a short circuit or open circuit, whether it is forward biased or reverse biased. And you can also explore more application in electronic circuit for rectifiers. If you have any queries or any doubt, you can post in the comment. I will definitely try to answer all your queries. Thank you for listening. Have a good day. Bye bye.